Alright guys, welcome to the wonderful world of factoring. In this video we're going to be factoring trinomials where the coefficient of the quadratic term is 1, and these are going to be really easy. In this video we're going to start working on developing our factoring skills. Factoring is going to be a critical skill that we carry with us throughout the rest of the year, so it's really important that you perfect every step of this now, so as things get a little bit more difficult, it's really just adding one more piece to the puzzle. So as we've gone over in class, and I will attach also to the Edmodo post, is the handout that I made. And towards the bottom of the handout, I talk about streamlining the process. Right? It's as easy as 1, 2, 3, and, well, maybe 4. Set up your two binomials. Okay, so the first thing I want to do is I just want to set up two binomials. Okay, and I want to take a look at this sign here, right here on the end. Since this is a plus, that means that the number in this position and this position, those are our last numbers in each binomial, they multiplied to give me a positive 32. Well, the only way I could multiply two numbers and have a positive anything is if they're both the same sign. And the middle sign tells me which one they are. So since this is negative, both of these signs are negative. Okay, now I say, well, let's set up our first terms by deciding the proper variable factoring. Well, what times what gives you x squared? And of course you'd say, well, x times x gives me x squared. So now what we want to do is just off on the side, list all the factors of 32. 1 times 32, 2 times 16, 3 times nothing, 4 times 8, 5 times nothing, 6 times nothing, 7, 8, and I just set a number that's in the list. There they are. So I'm looking for two numbers that multiply to 32. Well, all of them do that, and have a sum of 18, 2 and 16. Now, why a sum? Well, anytime we go to check our answer, and let's just be certain that these are the prime factors of the trinomial x squared minus 18x plus 32. So that's our quote-unquote answer. How would I check it? Well, I'd start foiling. So x times x, x squared of course. And then x times negative 16 is minus 16x. Minus 2 times x is minus 2x. And minus 2 times the negative 16 is plus 32. So there's my first, outer, inner, last, my foiling or multiplication of the binomials. And when I combine like terms here, what's going to happen? Negative and a negative is a bigger negative. This negative 18x, this piece right here, that was a sum. So I put right here in number 3, I list the factors over here. Then to decide if you're looking for a sum or a difference. Different signs mean that it's a difference. These are the same signs, so they're a sum. So if this was a positive and a negative, then they would be different signs. That would have meant that this 18 right here, this negative 18, was a difference. We're going to do some more practice, and I'll keep focusing on whether or not that was a sum or a difference, this linear term in the center here. All right, let's move on. In our first example at the top of the page here, we have x squared minus 3x minus 54. So just moving swiftly through this, let's decide on signs. You know, what signs are we going to put inside of our two sets of parentheses, our binomials? Well, 54 was negative, so that means that this number times this number, our last numbers, had to be both a positive and a negative, because that's the only way that I could multiply two numbers and get a negative answer. Okay. Now I said the next thing, step 2, would be to decide on our variable factors, so x and x, and trust me, this will get more difficult on the front side, but not just yet. X times x gives us x squared. So now we want to list all of our factors of 54. So we'll say 1 times 54, 2 times 27, and 3 times 18, 4 times nothing, 5 times nothing, 6 times nothing, 6 times 9, sorry about that, 7, 8, 9, okay, that's it, those are the 4. Now, since these are opposite signs, I'm looking for two numbers that multiply to 54 and have a difference of -3. So let's see, 54 minus 1 is 53, no. 27 minus 2 is 25, no. 18 minus 3 is 15, and 9 minus 6 is 3. We want that 3 to be negative, so the bigger number must be the negative number. 9 there, 6 here. Okay, now it says check your answer using the foiling method. So I'm going to write my check right here. So when I start foiling across, I got x times x is x squared. Then I got minus 9x plus 6x minus 54. And when I combine a positive and a negative, yes indeed, I'm going to get that negative 3x. So, box this up. There are my factors of x squared minus 3x minus 54. Moving on down to the bottom. T squared plus 5t minus 36. That 36 is a negative. Again, meaning that one of these is a positive and the other one's a negative. And it doesn't matter which one you make positive or negative. It matters where you place the numbers afterwards. T times t would give me t squared. And now we're going to list the factors of 36. 1 and 36. 2 and 18. 3 and 12. 4 and 9. 5 and nothing. 6 and 6. 7 and 7. 8, 9, so forth and so on. We've already doubled 6, so we're all set here. Now we're looking for two numbers that have a difference of positive 5t. And I think that you'll notice very quickly that once you have the factors listed out, it's so much easier to find that magic pair, 9 and 4. Now that 5 is positive, so that means our 9 must be the positive and the 4 is the negative. Because when we go to FOIL this out, of course, t times t is going to give me t squared, and 9 times negative 4 is going to be the negative 36. I'm not even really checking that. What I'm checking is the positive 9t and then the negative 4t. These are my inner and outer terms, and 9t minus 4t is a positive 5t. So, again, box this up. Those are our factors of t squared plus 5t minus 36. All right, we're on our last two examples now. As we look at our next example, p squared plus 25p plus 100, we notice that the 100 is positive, again, indicating that our signs are both the same. We go to the linear term in the middle to look at that sign to see which ones they are. That's positive, which means these are both positive. We have a p squared in the front, indicating that that is going to be a p times p. Factors of 100, let's write them down. 1 and 100, 2 and 50, 3 and nothing, 4 and 25, 5 and 20, 6 and nothing, 7 and nothing, 8 and nothing, 9 and nothing, 10 times 10, and that's all of them. So we're looking for a sum now, because both of these are the same. Same is a sum. Different is difference. Different signs, difference. Linear term is a difference. Same signs, sum. It's a nice little alliteration. Same signs is a sum. So we're looking for two numbers that have a sum of 25. Easiest seen when we have them all written out, 5 and 20. And it doesn't matter where you put the 5 or the 20 because they're both positive. And if you take the time to FOIL it out, you're going to get p squared plus 5p plus 20p plus 100. And when you combine your like terms, you're going to get 25p. So, again, box up our answer. There are the prime factors of p squared plus 25p plus 100. Prime meaning that both of those individual factors are not factorable themselves. Later on, we'll find that some of our factors are further factorable. Okay, last one, k squared minus 27k plus 72. Our 72 is positive, so what do we want to do? We know that both of the signs that are in the binomials are going to be the same. we're going to, we're going to look at that sign in the middle, which is negative, which tells us both of these are negative. Moving on, we got k squared, so that's a k and a k, because k times k gives us k squared. And then let's talk about factors of 72. And for factors of 72, truth be told, I had to take a minute and think about this one for a couple of seconds, but here they are. We got 1 and 72, 2 and 36, 3 and 24, 4 and 18, 5 and nothing, 6 and 12, 7 and nothing, 8 times 9, and 10 times nothing, 11 times nothing, and 12 is already in the mix. So we're looking for, again, these are same signs, so we're looking for a sum of 27. So just take a quick peruse through, and again, I think we find it pretty quickly. 24 and 3. So 24 and 3 are our winners, and it doesn't matter who goes first because they're both the same signs. And check your answer by foiling, and you're good to go. All right. Also attached to this post on Edmodo is page 235 from the book. We'll be working on questions 3 through 14 in class, along with some other questions at our next meeting. If you'd like, you can get a head start on it. Just know that whatever you don't finish in class will be due for homework, so having a jump start might be in your best interest.